Today we are going to solve problems of integrals based on substitution method. There are many others method also, like integration by part, integration by partial fraction. So the first method that we are going to follow is method of substitution. In this method we have to substitute some value and we can simplify with the help of given integration formulas. So see this question number 1. You can see this, you can observe this. If you differentiate 1 plus x square, you are going to get 2x. So here the substitution will be done. We'll assume let 1 plus x square equal to, generally we take t, but you can take any variable that you like to take. So here you differentiate with respect to t, because t variable you have taken. So this will be 1 upon, this is 2x, this is dx upon dt, and this is going to be 1. So you can this one differentiation of 1 will be 0. So you can write this 2x dx dt, you cross multiply, so you are going to get 2x dx equal to dt. So substitution will be done accordingly. You see your numerator is 2x dx, so that numerator can completely be substituted with dt, and this 1 plus x square. So this is going to be you have assumed this as t, so this is going to be t, or you can write dt upon t. So here you see that t is positive whatever value you take. So we can here just simplify that t is always greater than 0 whatever the value of x be. So here the answer will be log t plus c, because t is positive, so there is no need to apply mod t. So now you can again put the value that you assumed in the beginning, that this is 1 plus x square and this is c. So this is the answer of your question number 1 with the help of substitution method. Now see this question number 2. This is integration log x whole square upon x dx. So if you substitute log x as t, then you are going to get 1 upon x as the differentiation. So we can assume let log x, you can assume it whole also, log x whole square, or you can simply assume log x equal to t. So differentiate with respect to t, then you are going to get 1 upon x dx equal to dt. As we have done earlier, we are going to do it here. We are differentiating with respect to t. So now you have this, you see you can substitute dx upon x as dt. So we can write this as dt, and this is you assume this as t. So this is gonna be t square. So this integration has been converted into t square dt. Now you can apply the power rule. So according to power rule, this is t3 upon 3 plus c. Again now you can put the value that you assumed, t as log x whole cube upon 3 plus c. So this is the answer of your second question. Now see this question number 3. This is 1 upon x plus x log x. So we can simplify this first, that we can take x common, and then it will be 1 plus log x, this is dx. So you can start with let 1 plus log x as t. So differentiate with respect to t, so you are going to get 1 upon x dx equal to dt. So substitute this, this is you can see dx upon x, I can just mark like this, dx upon x. You can assume this as, this is dt, it is there, and you in the bracket term you assume this as t. So integration of dt upon t will be log. Now this time log x is positive. Again you see here that t is greater than 0. Reason being that log x is positive, 1 plus log x, then the complete this 1 plus log x is positive, so t is positive. So there is no need to apply mod. So simply write log t plus c. Now you can again substitute what you assumed in the beginning. T was, you assume this 1 plus log x, and you can write this as c also. or some of you may write this answer as log. One can be written as log e into e, this base e is, and this is log e x, this is plus c. So you can write that also, log bracket log, this is base e and this is ex plus c. So this is how you can write that also. This is not mandatory to write in this form, but it's you can use this way also. Now see question number 4. This is sin x into sine, and this is cos x. So this is the composition of function sine, and you have used this composition while you were using chain rule in differentiation. So you have to think, if I put cos st, then differentiation of cos x will be sine. So I can use this, let cos x is equal to t. So differentiate then with respect to t, then sin x dx, it will be equal to dt. So you can see that you have this sin x, you have this dx. If you take them together, so you can write simply sin x dx as minus dt. So minus you can put out, so this becomes your dt, and this sine, and inside you assume this as t. So complete integrand has come into the form of t. In terms of t, not form of t, in terms of t. Now sin t, you know the sin t, integration of sin t is minus cos t, and this is plus c. So minus and minus, this is plus cos t plus c. Now you can again simplify what you put in the beginning, t, you assume this as cos x. So this is cos into cos x plus c. This is your final answer. Okay, now next question, you see this is ax plus b dx. Now you cannot apply any rule directly, so you have to go with the substitution. So you can assume, let ax plus b as t square, or you can also say a root ax plus b as t. So here you differentiate with respect to t, then it will be a, this is going to be dx plus b is 0, and this is going to be 2t, and this is t. So you can now write dx as 2t upon a, and this is dt. So substitute. So you assume this as t square, so this will become t, and dx you calculate it as 2t upon a. A is a constant, you may take out, so this is dt. Now this becomes, this is t into t, this is 2 can also be taken out, this is 2 is also a constant, so this is t square dt. Now you can find the integration of this using power rule, this is t cube upon 3 plus c. So you can now again substitute the value, that t you assumed as, you can here root ax plus b, and this is whole cube, and this is plus c. So this is your answer of this part. Now next question is question number 7. Question number 7 is you have to integrate x root x plus 2 dx. Now you see this, can you solve it by using normal method? No, we cannot solve it directly. So again we have to take the help of substitution. So how we can start this? We can take, let x plus 2 as t square. So from here you will get x as t square minus 2. So you can now differentiate dx, this is 0, and this is 2t, and this is dt. So now you got the values, all the values. So x you replace with this t square minus 2, and this root x plus 2 you assume as t, and dx you have taken as 2t dt. So your answer is going to be, this is t square minus 2, and this is gonna be 2t square dt. 2 can be taken out common, you can now multiply, this is t4 minus this is going to be 2t square, and this is dt. Use power rule, so it becomes t5 upon 5 minus 2t3 upon 3, and this is plus c. So apply again that you assumed t as root x plus 2. So you can write root x plus 2, and this is whole 5 upon 5 minus 2 root x plus 2 square upon 3, and this is plus c. So this you have shown as the complete answer. See this question number 9. This is 4x plus 2 root x square plus x plus 1 dx. So we can again take let x square plus x plus 1 equal to t square. So when you differentiate with respect to t, you are going to get 2x plus 1 dx, and this is equal to 2t dt. So now you can substitute. How you can substitute? You see, if you multiply both side by 2, then what do you get? This is going to be 4x plus 2 dx, and here also then it will be 4t dt. So you can directly now substitute that 4x plus 2 into dx is 4t dt. So this is 4t and this is dt, and this you assume this as t. So this is t. So it's going to be 4t square and dt. You apply power rule. This is 4t cube upon 3 plus c. Again you can put the value that you assume. T you assume this is root x square plus x plus 1, and this is whole cube upon 3 plus c. So this is how you can solve this question. Now see this question number 10. Here it's again very difficult if you don't apply some trick that x can be written as root x into root x, and this is root x. Now root x can be taken common from the denominator, then root x, this will be root x minus 1, and this is dx. So here we assume 1, this is root x minus 1 as t we assume. So now we can differentiate with respect to t. When you differentiate with respect to t, then root x, the derivative of root x is 1 upon 2 root x, and this is going to be dx, and this is 0, and this is going to be dt. So now here you can see this is dx upon root x is 2. You can shift this side. So dx upon root x equal to 2 dt. So after shifting it, you will get it this as dt, and this as, you assume this as t. So this is t. So integration of this is log t, and log t, and you have to think first that whether it can be positive or it can be negative. Here it is possible that for some value of x, this quantity of t will become negative. So you have to apply this mod t and write this plus c. Now you can again substitute the value that you assumed. This is root x minus 1 plus c. So this is your complete answer of question number 10. Now this question number 12. Again you can see this question of difficulty is getting higher and higher as we are moving to the question. More than like 11th you have done, 10th you have done. Now this is 12th question. So even after doing this question number 12, the difficulty level will keep increasing. So you see this is x cube minus 1 upon 3 x5. So you start here with like x cube minus 1. This you can write as 1 by 3, and this x5 can be written as x cube into x square. Why I am writing this, you will get to know when I substitute this. Take x cube minus 1 as t. So, or you can say take t cube also, you can assume this, you can assume as t cube also. So if you differentiate with respect to t, then you are going to get 3x square, this is dx, and this is 3t square, this is dt. So 3 you can cancel. So wherever you are getting x square dx, you can substitute with t square dt. So here we start substituting that x cube minus 1, you assume this as, this complete one you assumed as t, because this, when you do the cubing both side, you will get this x cube minus 1 equal to t cube, but ultimately this is your t. So this is t, and now x3, you can find the value of x3 from here. I can use different pens so that you can differentiate from here. Your x3 will be t cube plus 1, that you can substitute wherever is x cube written. So x cube you will write this is t cube plus 1, and this x square dx is t square, this is dt. So ultimately now this is t cube bracket, this is t cube plus 1 dt. Now this is going to be t6 plus t3, this is dt. Now you can integrate, this is going to be t7 upon 7, this is going to be t4 upon 4 plus c, and ultimately you substitute the value, you assume this t as x cube minus 1 by 3, you assume t this is, so you take the power as 7 and this is 7, and here also x cube minus 1 by 3, and this is 4 upon 4 plus c. So now you can finally you can write this x cube minus 1, and this is 7 by 3 upon 7 plus this is x cube minus 1, this is 4 by 3 upon 4 plus c. So you may leave answer here, there is no need to simplify it further. In question number 10 we just missed out one, this 2, so here you have to write this as 2. So answer here you have to write 2 also. So just the small correction that you have to follow this. Now see question number 13. In this question if you substitute 2 plus 3x cube as t, then this is just giving hint, this is 3x cube, you take this as t, so your differentiation of with respect to t will be, this is 0, 3 into 3x square dx equal to dt. So this is gonna be your x square dx, 9 can be taken down, so your integration will become, this is dt, 9 can be taken out common because x square dx is dt by 9, and this you assume as t cube. So this you can write 1 by 9 and t minus 3, this is dt. So you can write this t minus 2 upon minus 2 plus c. Again you can substitute, this is 1 by minus 18, you can write here minus 18, and t you assume this as 2 plus 3x cube, and this is minus 2, this is plus c. So this way you can simplify question number 13. Now see question number 18. Here if you assume tan inverse x as t, then you differentiate with respect to t, then your differentiation of this is 1 plus x square. Differentiation of tan inverse x is 1 upon 1 plus x square, this is dx, and this is going to be dt. So you can now see that you have assumed this as t and this has come as dt, so it will become et, and this is dt, and integration of et will be et plus c. Now finally you can again substitute what you assume, this is tan inverse x, and this is gonna be plus c. So this you have seen that how we have solved this question number 18. So now come to question number 19. This is again very important question. e2x minus 1 upon e2x plus 1. This question was asked in CBSE exam, final exam. So you just better be take care this question how it can be solved. So first you take your intuition that if you take e2x plus 1 as t, then e2x is going to be t, so you are not going to get any help. So you see that how this complete one can be written. Can I write, you see this ex minus 1 upon ex, and this is ex plus 1 upon ex, because if you take LCM, this is ex into ex, e2x minus 1 upon ex, and this will be ex into ex means e2x plus 1 ex, LCM will be cancelled. Now after writing that equation, that integrand in this form, you can now assume let ex plus 1 upon ex as t. So you see the integration of differentiation of this will be ex, and this you can write Okay, I'm just writing this once again. This is t. Now you differentiate with respect to t, so it's going to be ex derivative is ex, and e minus x is minus ex, and this minus x is minus 1, and this is dx, and this is going to be dt. So now you can further simplify this. You can write ex minus 1 upon ex, and this is dx, and this is dt. So after substituting all these value, you are going to get this is 1 upon t dt, because you have assumed this as dt, and this you assumed as t. So 1 upon t. So now you are going to get log t plus c. Now exponential function is positive, always positive, so you have no need to put mod here. So this is log t plus c. Now just finally substitute log t. You assume t as ex plus 1 upon ex and plus c. So you may leave answer here only, no issue with this. Okay, now consider this question number 21. This is tan square 2x minus 3 dx. Now you don't have integration for tan square x, but yes, you have integration formula of sec square x dx. You can write this as tan x plus c. So this formula you have, but you don't have the formula for tan square directly. So we can we have one more formula, that 1 plus tan square x equal to sec square x. So ultimately, using these two formulas, I can write this integration as sec square 2x minus 3 minus 1, this is dx. So now what you can do, you can convert that into integration. This is 2x minus 3 dx, and this is 1 dx. So now here this is fine, you can write this as x, but here you can use 2x minus 3 as t. After practice, you need not to assume 2x minus 3 as t always, because you can write the answer directly after understanding these few examples. So for example, sec square, the integration of sec square is 10x, so you can write 10 2x minus 3, and 2x minus 3 you do differentiate and write in the denominator. So you see that how it comes. So now it is 2 dx, and this is dt. So dx is going to be dt by 2. So you apply this here. So it is going to be sec square t. This is dx को आप replace करेंगे 2 से, and so this is, you may continue with dx, and this is now 10t, and this minus 1 is there, so you can write this minus x, and this is plus c. Again you substitute what you assumed. This is 2x minus 3 minus x plus c. So this way you can see this 2 was in the denominator, so it will remain here 2, and this is here 2. So this is the answer of your question number 21. Now after understanding this question number 21, I want you write the answer of this directly. Sec square, this is going to be 10 7 minus 4x, and differentiation of this you have to write below. So minus 4, and this you can write c. If you cannot write it like this, so you may also do alternative is for you that you take 7 minus 4x as t, and then you can simplify. So try to learn how to write this directly, because in many questions you have to write this directly. Now consider this question, sin inverse x root 1 minus x square dx. So first I just want to tell you that sin inverse x derivative is 1 upon root 1 minus x square. So you can get the hint from this formula that you have to assume sin inverse x as t. So that is going to be 1 upon root 1 minus x square dx equal to dt. So substitute, this is your now this is your dt, and you assume this as t. So t dt, and you can integrate this t square upon 2 plus c, and t you assumed as sin inverse x. So sin inverse whole square upon 2 plus c is your answer. Thank you. Please share, subscribe if you have liked this video. Thank you.